Hello students, in this lesson we will learn about the various types of networks available for mobile phones like 3G and 4G. In current era, being a part of techno-savvy world, users send email and surf the web at any time and from anywhere from their mobile. Mobiles are now multimedia devices delivering a variety of applications including music, games, videos, internet and emails among others. Mobile and wireless networks have made tremendous growth in the last 15 years. There are 5 generations of wireless telecommunication technology, from first generation, that is 1G, to 5th generation, that is 5G. Let us discuss each one in detail. The first generation of wireless telecommunication technology was introduced in 1980 and is known as 1G. The main difference between the existing system and 1G was invent of cellular technology, and hence it is also known as the first generation of analog cellular telephone. In first generation, the geographical area is divided into cells, typically 10 to 25 kilometers, each served by a base station. Cells are small so that frequency reuse can be exploited in nearby, but not adjacent cells. This allows many more users to be supported in a given area. All 1G systems were analog systems, popularly known as early cellular phone technology, working in the frequency band of 150 MHz. Important keys of 1G. Developed in 1980 and completed in early 1990. 1G was old analog system and supported the first generation of analog cell phones, speed up to 2.4 kbps. Advanced Mobile Phone System AMPS was first launched by the US and is a 1G mobile system. It allows users to make voice call within a country. Disadvantages of 1G: analog technology, poor spectral efficiency, voice only technology. Two G cellular telecom networks were commercially launched on the GSM Global System for Mobile Communication standard in Finland in 1991. 2G networks allows for much greater penetration intensity. 2G technologies enable the various mobile phone networks to provide the services such as text message, picture message and MMS, multimedia message. 2G technology is more efficient. 2G technology holds sufficient security for both the sender and the receiver. All text messages are digitally encrypted. This digital encryption allows for the transfer of data in such a way that only the intended receiver can receive and read it. The main difference between 1G and 2G is the radio signals. 1G networks are analog while 2G networks are digital. Second generation technology are either time division multiple access TDMA or code division multiple access CDMA. TDMA allows for the division of signal into time slots, whereas CDMA allocates each user a special code to communicate over a multiplex physical channel. Different TDMA technologies are GSM, PDC, IDEN, IS-136, while CDMA technology is IS-95. GSM, that is Global System for Mobile Communication Technology, was the first one to help establish international roaming. This enabled the mobile subscriber to use their mobile phone connection in many different countries of the world which are based on the digital signals. It is a digital mobile telephony system that is widely used in Europe and other parts of the world. GSM operates in frequency bands 900 MHz, 1800 MHz, 1900 MHz. It provides voice and data services. Unlike 1G technologies, which were used to transfer analog signals, GSM is the most admired standard of all the mobile technologies. CDMA, code division multiple access, it is a sort of multiplexing that facilitates various signals to occupy a single transmission channel. It optimizes the use of available bandwidth. The technology is used in ultra-high frequency UHF cellular telephone systems in the 800 MHz and 1.9 GHz band. CDMA assigns unique codes to each communication to differentiate it from others in the same spectrum. In a world of finite spectrum resources, CDMA enables many other people to share the airwaves at the same times than do alternative technologies. Short Message Service (SMS). SMS is a mechanism of delivery of short messages up to 160 characters to mobile devices including cellular phones, smartphones and PDAs. It is a store and forward way of transmitting message to and from mobiles. The message text only from the sending mobile is stored in a central short message center (SMS), which then forwards it to the destination mobile. This means that in the case that the recipient is not available, the short message is stored and can be sent later. SMS is a cheap and easy way to send a message to anyone other than the voice call or conference. This technology is beneficial to both the network operators and the ultimate users at the same time. 2.5G is a stepping stone between 2G and 3G cellular wireless technologies. The term second and a half generation is used to describe 2G systems that have implemented a packet switched domain in addition to the circuit switched domain. It does not necessarily provide faster services because bundling of time slots, it is used for circuit switched data services (HSCSD) as well. The first major step in the evolution of GSM networks to 3G occurred with the introduction of General Package Radio Service (GPRS). GPRS is a method of enhancing 2G phones to enable them to send and receive data more rapidly. It can be used for services such as wireless application protocol, web access, multimedia messaging services (MMS), and for internet access such as email and World Wide Web access. GPRS is a packet-oriented mobile data service on the 2G and 3G technology. Packet switching is where data is split into packets that are transmitted separately and then reassembled at the receiving end. (2.75G) is a term occasionally used to refer to the edge data connectivity, implying that it is faster than GPRS but slower than typical 3G networks. Edge enhanced data rates for GSM evolution increases the speed of each time slot to 48 kbps and allows the use up to 8 time slots, giving a maximum data transfer rate of 384 kbps. In places where an edge network is not available, GPRS will be used automatically. Edge offers the best that can be achieved from a 2.5G network and will eventually be replaced by 3G. International Mobile Telecommunication 2000 (IMT 2000), better known as 3G or third generation, is a generation of standard for mobile phones and mobile telecommunication services fulfilling specification by the International Telecommunication Union. The use of 3G technology is also able to transmit packet switched data efficiently at better and increased bandwidth. 3G mobile technology offers more advanced services to mobile users with transmission speeds from 125 kbps to 2 mbps. In 2005, 3G is ready to live up to its performance in computer networking, WCDMA, WLAN and Bluetooth, and mobile devices area, cell phones and GPS. Data is sent through technology called packet switching. Voice calls are interpreted using circuit switching. It provides access to global roaming. It provides clarity in voice calls. With fast communication, internet, mobile TV, video conferencing, video calls, multimedia messaging services, MMS, 3D gaming, multi-gaming, these are also available with 3G phones. (4G) refers to the fourth generation of cellular wireless standards. The bandwidth and location information available to 3G devices gives rise to application not previously available to mobile phone users. 4G is able to provide very smooth global roaming with lower cost. Some of the applications are mobile TV, A provider redirects a TV channel provides to the subscriber phone where it can be watched. Video conferencing. Subscriber can see as well as talk to each other. Location based services. A provider sends localized weather or traffic condition to the phone, or the phone allows the subscriber to find nearby businesses or friends. Mobile ultra broadband, gigabit speed access and multi-carrier transmission. "5G is also called as 5th generation mobile networks or 5th generation wireless system. The implementation of standard under a 5G umbrella would likely be around the year of 2020. 5G is a completed wireless communication with almost no limitation. Somehow, people called it real wireless world. It provides additional features on mobile such as multimedia newspaper and TV programs with the clarity almost like an HD TV. BTS, Base Transceiver Station. The BTS is a telecom infrastructure used to facilitate wireless communication between subscriber device and telecom operator networks. The subscriber device can be mobile phone, wireless internet device, while the operator networks could be a GSM, CDMA or TDMA platform. A base station control (BSC) is a critical mobile network component that controls one or more base transceiver station (BTS). It is an interface between BTS and it is linked to BTS by cable or microwave links. It routes call between BTS. It also connects to the MSC. Mobile Switching Center, the coordinator of a cellular network which is connected to several BSCs. It routes call between BSCs. A BSC works with a mobile switching center (MSC) component that is external to the BTS, enabling it to provide full mobile telephony and full capacity requirements. Base station must communicate with the MSC and data must be managed as information overflow, impacting MSC efficiency. A BSC eliminates MSC base station activity management requirements, allowing the MSC to handle critical tasks such as traffic balancing and database management. Component of a cellular phone MSU mobile subscriber unit. Radio transceiver is a low power radio transmitter and receiver antenna usually located inside the phone. Control circuitry. It formats the data sent to and from the BTS. Control signal transmission and reception man-machine interface. It consists of a keypad and a display. It is managed by the control circuitry. Subscriber Identity Module (SIM), integrated circuit card that stores the identity information of subscriber. Battery is the power unit of the phone. When the phone is powered on and it does not have a frequency or time slot or a code assigned to it yet, so it scans for the control channel to the BTS and picks the strongest signal. Then it sends a message including its identification number to the BTS and it indicates the presence. The BTS sends an acknowledgement message back to the cell phone. The phone then registers with the BTS and informs the BTS of its exact location after the phone is registered to the BTS. The BTS assigns a channel to the phone and the phone is ready to receive or make calls. The subscriber dials the receiver's number and sends it to the BTS. The BTS sends it to the BSC, the ID, location and number of the caller, also the number of the receiver. The BSC forwards this information to its MSC. The MSC routes the call to the receiver's MSC, which is then sent to the receiver BSC and then to its BTS. In this way, the communication with the receiver's cell phone is established. When the receiver's phone is in idle state, it listens to the control channel of the BTS. If there is an incoming call, the BSC and BTS sends a message to the cells in the area where the receiver's phone is located. The phone monitors the message and compares the number from the message with its own. If the number matches, the cell phone sends an acknowledgement to the BTS after authentication. Then the communication is established between the caller and the receiver. The entire network coverage area is divided into cells based on the principle of frequency reuse. A cell, basic geographical unit of a cellular network, it is the area around an antenna where a specific frequency range is used. It is represented graphically as a hexagonal shape, but in reality it is irregular in shape. When a subscriber moves to another cell, the antenna of the new cell takes over the signal transmission. A cluster is a group of adjacent cells, usually 7 cells. No frequency reuse is done with the cluster. The frequency spectrum is divided into sub-bands and each sub-band is used within a cell of the cluster. In heavy traffic zones, cells are smaller, while in isolated zones, cells are larger. Macro cell. Their coverage is large, approximately 6 miles in diameter. Used in remote areas, high power transmitters and receivers are used. Micro cells. Their coverage is small, half a mile in diameter, and are used in urban zones. Low power transmitters and receivers are used to avoid interference with cells in another cluster. Picocells. Covers area such as building or a tunnel. Handover. Moving a call from one zone, from the transmitter receiver from one zone to another zone due to subscriber's mobility. Roaming. Allowing the subscriber to send or receive calls outside the service provider's coverage area. Frequency reuse. It is a method used by service providers to improve the efficiency of a cellular network and to serve millions of subscribers using a limited radio spectrum. It is based on the fact that after a distance, a radio wave gets attenuated and the signal falls below a point where it can no longer be used or cause any interference. A transmitter transmitting in a specific frequency range will have only a limited coverage area. Beyond this coverage area, that frequency can be reused by another transmitter. In this lesson, we have discussed about mobile phone networking, which includes evolution of mobile networks, global system for mobile communication (GSM), code division multiple access (CDMA), GPRS, components of mobile networks, network cells, etc. As we know that mobile networks are quickly becoming the networks of choice, not only because of large bandwidth, but due to flexibility and freedom they offer. With increased frequency allocation, advances in semiconductor technology, and more efficient coding of information over wireless channels, mobile networks have become the network of choice for most users and applications.